Hello and welcome back to my channel. And in this video, we will be talking about the generative AI pipeline in some more details. And if you have watched my previous video, so we briefly discussed about all of these steps which are involved in the generative AI pipeline. So we will be focusing some more time on the data acquisition, data preparation, and the feature engineering part. So once we will cover these details, then we will move on to the coding section in the next video, and we will be doing the hands-on implementation of the whole generative AI pipeline. So let's begin. So as we discussed in the previous video as well, that one of the first step in the generative AI pipeline is the data acquisition. And again, the purpose of the data acquisition is to get the data for our generative AI application, because again, without data, we cannot train the model. And the idea is to get as much data as possible. Okay. So that is the main objective of the data acquisition. So how we can get the data so that we can train our model in the coming steps. So different options available. One of the option we have is to get the data from some predefined formats. For example, we can get the data from the text format. We can get the data from PDF files or Excel sheets, Word format. So that is one of the source of data that is available. Other than that, we can also get the data from the databases, okay, or we can use the APIs in order to get the data from some other website. So, for example, here we have a remote server or a remote website. For example, this is weather.com. This will give us all the weather related information. So we can call the API to get the weather related information for, let's say, last 1 month or last 1 year, or maybe more than that, in order to train our model. And in return, we will get the data. Most likely, the data will be in the JSON format. Okay. So that is another way of getting the data for our generative AI application. If all of these options are not available, another option we have is to directly ask the large language model. Okay, or for example, the Chat GPT. We can just go to the Chat GPT and we can write a beautiful prompt and asking the Chat GPT to give us the data about any specific subject. So that is another way of getting the data, because again, all of the large language models or the, for example, the Chat GPT, they all are trained on the data which was available on internet. So they were trained on the data which was available on internet, plus some of these sources as well, like text, PDF, databases, all of that stuff. So you can also ask the Chat GPT to get some of the data for you. So that is the first step, that you need to get the data so that you can train your models later on. It is possible that by the end of the first step, you have get some data, like some data you got from PDF, from databases, and some data you got from the APIs, but still you don't have enough data. So for example, let's say you have, if you just calculate all of the data, for example, the total data you have is around 1 GB. Okay, so again, and you have determined that the 1 GB of data is not enough to train your model. So what you can do, you can add some more information. So if you feel that you have less data available, then the other option which you can do, once you feel that you have less data information available, you can perform the data augmentation. You can perform the data augmentation. So the purpose of the data augmentation is that the data which you already have available, so how you can build on that data, how you can increase the data based on the available data or based on the available information. So that is the main objective of the data augmentation, because again, the goal is to have as much data as possible, and the data must be relevant. Okay, the data should not be a garbage data just to increase the number of information. So let's say the objective we have is to, you want to go from 1 GB to 2 GB of data, and that you feel would be enough to train your model. So for that, you will have to perform the data augmentation. Okay, now in the data augmentation, there are different options available. For example, one of the option available under the data augmentation is called the with replace with synonyms. Okay, so that is one of the option available, which is called replace with synonym. So for example, if we go here to the chat GPT, and if I just wrote a prompt that please replace the following sentence with synonym. So in the sentence we have that I am a software engineer, and the synonym we have for this is I am a software developer. So again, I am a software engineer, I am a software developer, they are almost the same thing. So again, that is the synonym. Or for example, you have a sentence in the data that I am a doctor. So the synonym of that would be I am a physician. So what you can do, so if you have this sentence, just one sentence, so you can make two sentences out of one sentence. So you can just add this sentence as well. So I am a doctor, somewhere you will say I'm a doctor, somewhere you will say I'm a physician. So you are adding some more information, but it is still within the context of the area which you are working on. Okay, so that is the basic idea of adding the synonym information or replacing your data with the synonyms. So that is one of the option available that you can use, which is coming under the data augmentation. Okay. If you have instead of text, if you have the data in images, so how we can work on that? So for example, if we go to Google and if we write here uh, image augmentation, and if we look at the images, so we can see here, for example, if we open an image, let's say this one, okay, and if I increase the size a bit, so we can see here that okay, so we have the original image. Okay, this is the original image, and to do the augmentation, basically to increase the data or to have different versions of the same data. So these are all the augmented versions. So for example, this is the original image. So here you have the horizontal version. Here you have the vertical version. Here you have like 45 plus rotation, negative 45 rotation, a blurred image, okay, grayscale, darker, so you have different versions. So basically at the back it is the same original image, but you have created different copies or different versions of the same image. So that is again, if you have the data available as images, so you can also do the augmentation of that. Other than that, if you have the data available in text, so how you can create different versions of the same text. So simply you can ask the chat gpt, you can give the whole paragraph, and the chat gpt will create a synonym of that text. Okay, so that is how we can work with the data augmentation for text and for the images. Okay, then under the data augmentation, another option you can use is called the bigram flip. So bigram flip, okay. So bigram flip basically means that if you have a sentence, so for example, in bigram flip, let's say if you have a sentence, let's say my name is Amir Khan. Okay, so you can create another version of that using the bigram flip, that Amir Khan is my name. Okay, so same thing, same meaning, but two different versions. So you have added some more data. Okay, so that would be useful during the training of your model. So the first one we have is the data augmentation, and within the data augmentation, you can replace the data with the synonyms for both for the text and for the images. And secondly, you can do the bigram flip. So this is one of the example we saw. So these are the two options we have under the data augmentation. And again, the purpose of the data augmentation is to increase the data which is still relevant for your model. Okay, then The third option which is available under the data augmentation we have is called the back translation. So back translation, I will just write it here. Back translation. Okay. Now, what is again, the goal is to increase the data, and for that we can also use the back translation. So how this will work? So if we go to Google, for example, I will copy some data. For example, let's say I will copy this text here. So this is the text data we have available, and we want to do the data augmentation using the back translation. And so I've just copied this text, and if we go to the translation, and if I paste the text which is in English, and if I translate it in, for example, uh, in uh, in Arabic, let's say, okay. So I have translated this in Arabic, okay. So this is the first step of the translation. Then what I will do, okay, one second, let me paste it again, and let me, okay. So I have translated that in Arabic, and let me copy this translation, okay, and I'll come back here, and here I will paste. Okay, so it has detected the language as Arabic. Now I will translate it back again into let's say some other language. Let's say maybe Spanish or French. Okay, so here we have French. Okay, so I have translated this into French. Okay, then what I will do, I will take again this translation, copy, paste. So French has been detected, and now I will translate it back into English. Okay. So these are the two steps that we'll have to perform. Okay. So it has given us the translation for that. Okay. Now, if we look at the translation, so that is the idea of the back translation. Now, this translation would be little bit different than the original text. Okay, so this translation would be little bit different than the original text. But again, for a very small paragraph, you may not see the real impact. So, for example, here I'm uh, just putting the translation into a notepad. So this is the translation, and if we go back to Google, and if we look at the actual text that we have here, we have the actual text, and here I have copied the actual. So as we can see, the length is already different, which means there is some difference there. So is the technique that expands. So here, this is the difference. It enlarges. It says it expands by creating new versions. So yeah, we have some differences. Improving model general work by, especially when data is limited, especially when training data is limited. So again, this is just very small paragraph, so we can see the difference. Okay, so if you have a long paragraph and if you do the back translation, so you can see some major differences. So back translation is again very effective, and it's very easy to perform. You can just use the Google for that. So that is another example of expanding your data. So imagine if this is your original data and you have done the back translation. So here you have another version of the information. So this is another way of increasing the data using the data augmentation. So that is the whole idea of the back translation. Okay. Then another method that can be used, that is called that is simply to add some more information. So add additional data or additional noise. Okay, so for example, I'll just write here that additional additional data or adding additional noise. Okay, so adding additional data or adding additional noise simply means that if you have a sentence, okay, so let me go back to the notepad. So additional noise. Okay. So if you have a sentence that I am an AI engineer. So this is the whole sentence you have. I am an AI engineer. So what you can do to add the additional noise, you can say that I love my job. Okay. Okay. So that is you have just added some additional information just to improve or increase the memory size or increase the data. So you have just added something additional. Okay, you can add anything, but the real context will be here. I am an engineer, I'm an AI engineer, and you will just say that, and I love my job. So you have just added some more information, some more additional data or additional noise. Okay, so these are some of the techniques which can be used, which are coming under the data augmentation. And data augmentation will be used if during the data acquisition process you feel that you have less data available. So that is all about the data acquisition. All right. So we talked about the data acquisition, and now once you have enough data available in any format, in JSON format or in PDF or any other format, so once you have the data available as part of the data acquisition, the next step you have is to prepare your data. So that is the data preparation. So let's see what details we have for the data preparation. And okay, so for the data preparation, we have some basic techniques and we have some advanced techniques. Okay, so we have both type of techniques available here. So if we talk about the basic techniques, one of the option we have as part of the basic techniques under the data preparation, we have tokenization. Tokenization. Now again, before we come to the data preparation, we are assuming that we have the data available. Okay, we have the data available as part of the first step, which is the data acquisition, and now we are doing the data preparation. So data preparation means we are making the data more readable. We are just doing the basic formatting, and we are cleaning the data. So that is the purpose of the data preparation. So under the data preparation, one of the option we have is the tokenization. Okay, so for tokenization we have two options available. One is called the sentence level tokenization, and the other one we have is the word level tokenization. Okay, so the basic idea of the tokenization is that we want to break the whole paragraph. So if you have here, like it's a PDF file, for example. Okay, it's a PDF file and it has lots of paragraphs and all of that stuff. It's, let's say, 10 MB of data, and now you want to do the tokenization. And the reason is that you cannot give the whole PDF, which is of 10 MB, okay, which is of 10 MB directly to your model. So that would be very difficult to for your model to digest the whole 10 MB. So what you want to do, you want to break this 10 MB into different chunks. Okay, so for that we'll be using the tokenization. So we have sentence level tokenization and the word level tokenization. So for example, let's say we have a sentence or couple of sentences, and the sentence is, my name is Amir, and then I am an AI engineer, and I am PMP certified, and I am PMP certified. Okay, so this is the whole paragraph you have. Now to do the sentence level tokenization, you will break this whole paragraph based on the sentence. So the system will automatically detect. So the first sentence we will have here. So this is the first sentence. Okay. Then we will have the second sentence. So it is starting from here till here. Okay. So that is the second sentence. And this is the third sentence. Okay. So once the whole paragraph will be broken down into sentences, then each sentence would have some numerical representation. Okay? Because again, models, they don't understand this text or image or any other format, they only understand the numbers. So each sentence will be converted into numbers. So for example, I am PMP certified, so for example, this will be converted into 1023 or anything else, just as an example, and then this will be fed into the model. So that is the basic idea of the sentence level uh, tokenization. Now the other option we have, which is the word level tokenization. So word level, as it says, that each the whole paragraph will be broken by word. So this is first word, second, third, fourth, so all of these words. And then for each word, it will have its own numerical representation, okay, or a number code, and then each word will be fed into the model. Now we have the option that while doing the word level tokenization, do we want to consider just one word, or we can have two words as one word? So later on we will see. So this normally is the property like n equals to 2, for example. So this is one of the property we will specify, which means that it will consider two words as a single word. Okay, so again, it has some benefits as well if you want to, specify this property. But as of now, the word level tokenization means that the whole sentence, the whole paragraph will be broken down based on the word level. Okay, so these are all the words, and then each word will have its own representation. So that is the basic idea of the tokenization. So you have a full paragraph, or let's say you have huge amount of data, so you will have to do the tokenization. And in the next videos, we'll be doing the hands-on Python examples, that how to do all of these steps. But this is just the theoretical part. So that is the tokenization here. Okay. After the tokenization, and the next thing that you will have to do, uh, so as part of the data preparation, after the tokenization, the next thing you will have to do is the stop word removal. Stop word removal. Okay, so stop word removal means, again, you have here this data which is in PDF format. Okay, all of that stuff. And here in the text related information, you may have, for example, some HTML tags. Okay, you may have some HTML tags, that is possible. So you want to get rid of those HTML tags. So HTML tags, for example, you have a tag ahref. Okay, or you have some other tags. So if you're familiar with the HTML, so again, you don't need all of these tags, these are irrelevant. Again, what you want to fed into the model is the actual word, okay, or the actual sentences which make sense. But these tags, again, doesn't make any sense for the model. So you can get rid of all of these HTML tags. Or for example, you have emojis. You have emojis in your text, so you want to convert your emojis into the number, because each emoji has a numerical representation at the back. Okay, so either you remove the emojis, or get the numerical representation for all of the emojis. So removing the HTML tags, and getting rid of the emoji. So that is the basic idea of us removing some of the stop words. Okay, then after removing the stop words, another option which can be done to prepare your data, so we have, is called the stemming. So we have two options which are related. So we have stemming and we have the lemmatization. Lemmatization. Okay. Now what is stemming? So for example, you have a word. You have a word, for example, sleep. Okay, and you have another word, sleeping. Okay, and then you have another word, slept. Okay, so these are the three words. Okay, now stemming means, so if we talk about the stemming means you want to know the root of these words. Okay, so you have sleep, sleeping, slept. Okay, so you have these three words. Now the root of all of these words is sleep. Okay, the root of all of these three words is sleep. So what you can do, you can just replace all of these, the remaining of the two words with sleep. The model will get the idea. Okay, so that is the purpose of the stemming. So stemming means you want to know the stem or the root word for a different related words. So sleep, sleeping, slept. So sleep is the root of all of these words. So that is the stemming. And then we have another option which is called lemmatization. So lemmatization is almost the same thing, which we will see when we will be doing the hands-on Python. But lemmatization is more common to use, whereas stemming is less common. Okay, because again, sometimes when we want to know the root word for different words, so sometimes the model will generate irrelevant word or a word that is not that much understandable by the model. So stemming is not very common, whereas lemmatization is very common. But we will see the actual implementation of lemmatization when we will be working on the Python code. Okay. So that is, these are the two options we have, stemming and lemmatization, and previously we looked into the stop word removal as part of the data preparation. Another thing that can be done to prepare your data, and that is the punctuation removal. Punctuation removal. So punctuations you have, for example, exclamation mark. Okay, you have semicolons, you have colons. Okay, so some of those punctuation marks you can just remove. Again, these will just increase the data unnecessarily. You don't need, that amount of data which doesn't make any sense. So punctuation removal, you will just remove all of those punctuations. Okay. Then another option that you will have to do is to convert all of your data into lowercase. That's part of preparing your data. Convert the whole data into lowercase. And the reason would be that, again, let's say you have a data, for example, a name, let's say, sorry, a second. So here you have, for example, a name. Let me just write it again. AMIR. Okay. And then somewhere else, the same name is mentioned like this. Okay, somewhere it is mentioned like this. Okay, now same thing, same meaning, same name, but somewhere it is uppercase, somewhere it is lowercase. Now each word would be having a different translation, or would be having a different numerical representation, because capital A, small a, again, both will have a different numerical representation. Okay, so you are just adding unnecessary data. So what you can do, before you convert your data into numerical representation, you will just convert all of this paragraph, each and everything, into lowercase, so that it will not just create the numerical representation for the duplicate or similar kind of information. So convert the data into lowercase. Okay. So these are some of the things that you can do as part of the data preparation, and these are all the basic things that you must have to perform before you submit or you fed the data into the model for your generative AI. So apart from the basic techniques, we have some advanced pre-processing techniques as well. So for that, if we look at this information here, for example, uh, now what we have here, let me change the color first. Okay. So what we have here, let's say this is the sentence. Input is that the chaplain wrote, directed, and composed the music for most of his film. So that is the data which we have available in any format, PDF or in text format. Now we talked about the tokenization. So tokenization with lemmatization. So for example, it says chaplain. Okay, fine. So chaplain will stay as it is. Chaplain wrote will be converted into write. Directed is being converted into direct. And for example, this is again compose the music for most of most of, again, here we have for most of he films, so most of his films, for the model maybe that would be the right thing to understand, but this is the basic idea of tokenization with lemmatization. Okay. Another feature which is coming under the advanced technique, which is called the POS, or the parts of speech tagging. So parts of speech means we have some nouns, we have some verbs, okay, we have some adjectives. Okay, so that is what it will do. It will identify the parts of a speech. Okay, like which one is the verb. So this is the verb, this is the verb. Okay, and like all of the nouns and verbs, so this is a noun name, chaplain is the noun, and so on. So it will identify the parts of speech. So again, you don't need to worry. In Python we can use libraries and it will automatically do the work for us. Once will be working on the next videos, we will see all of those things in the real implementation. So this is the parts of speech tagging. This also needs to be performed. Tokenization also needs to be performed. And before that, we looked into the stop word removal and the tokenization. Okay. Okay. And then a parse tree will be created. Okay. So this will again be done automatically by the using the Python libraries. So parse tree is, we have a tree and which says that, okay, which word belongs to the noun, which word belongs to the verb, and so on. So a complete tree will be created. So that way it is very easy for the large language model to identify any new sentence. So that is the purpose of the parse tree. Another another thing that can be done as part of the advanced pre-processing, that is called the co-reference resolution. Okay. So co-reference resolution means that if you have a subject which is being mentioned in the sentence more than once, so a reference will be created. For example, it says that the chaplain wrote most of the music for of his films. Okay, so here we have a co-reference that chaplain by name has been mentioned here, and then the chaplain has been mentioned here as well, so it is the same subject. Okay, so this is the first mention, this is the second mention, and a co-reference has been created. Okay, so again, we just need to know the theoretical part. Python will take care of all of these things automatically, but that is the basic idea of the co-reference resolution, because a subject can be mentioned more than once, but here we have the name, but here we are not using the name, we are just saying his films, which means it is understood that here we are talking about the chaplain as well. So these are some of the advanced level techniques that can be used. So we have seen the data acquisition. So if you go back, so we have seen here the data acquisition and the data preparation, that how to work on that. So these are the two very important and critical steps as part of the generative AI pipeline. So again, once you have the data, you need to prepare your data, and later on we'll be doing the feature engineering. And for the feature engineering, we'll be using the transformer model, which is most of the generative AI models are using the transformer model. So for all the remaining steps, for all the next steps, we'll be working in the next videos in the Python, and there we will see how to perform all of the generative AI pipeline using the Python code. So I hope this is giving you some more clarity about the whole pipeline. And thank you for watching this video, and I will see you in the next video with Python code.